Good morning, good afternoon, good evening. Whenever you're watching this video, I hope you're doing good. What we are about to get into, circle equations. You, in your previous lesson, learned about how to use a center and a radius in order to come up with the circle equation. What we're going to do today is we're going to do the opposite of that. I'm going to give you the equations and see if you can come up with the circle, or I may give you just the circle and ask you to come up with the equation. And so I'm just going to quickly run through a couple of examples here and just kind of remind you of what you should be doing. Hopefully this isn't going to be too difficult. So with this very first one, we have x squared plus y squared is equal to 36. Now, I just real quickly want to review the formula for a circle, which is x minus h squared plus y minus k squared. Should be on the outside, inside. There we go. Squared is equal to the radius squared. All right. Now, if I look at the equation I'm given in number one and compare it to the equation I just wrote out the example, there's some things that are missing. So let's just go ahead and fill the things in that are missing. Well, we don't have an h, so since I don't have it, I'm going to put a 0 in its place. We don't have a k, so I'm going to put a 0 in its place. And then we have 36. Now, as a result, hopefully you can see that the center is going to be just at 0, 0. Now, we don't have to worry about the positive or negatives when we're looking at the 0 because it doesn't matter. Okay, 0 is neutral, has no power as far as positive or negative, so we can just put that in 0, 0. Okay. Now, your radius squared is right here. So in order to do a square, we've talked about this before, we're going to square roots that. And so I don't want to see this actually, I want to see you simplify your radius lengths, and so that would be the answer to that one right there. We're going to graph a circle at 0, 0 with a radius of 6. So here, 1, 2, 3, 4, 5, 6. As we talked in the previous lesson, 1, 2, 3, 4, 5, 6. We are going to go up, down, left, and right, whatever the radius is. And we plot those 4 points, and then from there you can just connect them as your circle would be. Okay? Now, next thing, number 2, a little more complicated. We've actually got our h and our k. Okay? Now, you'll notice here that in the original equation it's x minus h. And so whatever we have over here already has a negative next to it. And so if it helps to think of it like this, the easiest way to put it, since there's a negative already present here, as here, the number is the number that you're going to take. Okay? And so your center for this problem is just going to be 2, 7. Now, once you've looked, hopefully you saw this in our previous lesson, but it's that the x and y values that you're going to pull out for your center are going to be the complete opposite value of what's already in the equation because of the negative that was present within the original formula, okay, the standard form formula, okay, for a circle. So from there, I take my radius length, which is going to be the square root of 49, which we know ends up being 7, okay? Now, if your radius length doesn't end up being a whole number, a perfect square, I would like it in simplest radical form. If it has a decimal with it, then I'll let you go ahead and square root it, but my preference is in simplest radical form. Now, I'm not going to go ahead and worry about graphing that one because I feel pretty confident that once you have that information, you would be able to go ahead and graph it, okay? For the third example, if you want to pause your computer and go ahead and give it a shot yourself, you can do that. But here's what we have. We have a center, which is going to be at the opposite value, remember, so negative 3, and the opposite value, positive 1, and then the radius is going to be at the square root of 12. Now, I would like you to simplify that. If you remember, 2 times 2 times 3 gives us 2 radical 3, that's your radius. But that doesn't necessarily help us when we want to go ahead and graph that because we don't know, well, what is 2 radical 3? Is that like 2 point something? Is that 3 point something? And so that's when we're going to pull out our calculator. And we can just go ahead and type in 2 radical 3, and we get approximately 3.5 as the radius length. And so make sure when you graph this, -3, +1, that you go your 3.5 units in the 4 different directions from there to graph your circle. Okay? Now, if you go to the back side, you no longer have the equations, but you have the graphs, and you have to come up with the equations. So, what do we have to do here? Well, we have to first of all figure out what the center is, what the radius is, and then plug it into the equation. And so as I look at this number 4, we can see that the center is going to be at 0, 0. All right? Now your radius, it's going to be important that when you look at a graph, you identify how much each tick mark is worth, how much each one of these markings is worth. So for example here, if I count out 1, 2, 3, 4, I know that each one has a value of 1. Okay? I know on some of these other graphs it may be a value of 2, or maybe a value of 5 or 10. And so just keep that in mind as you look at your graphs here. So the radius here has a radius of 2. Okay? So as a result, when we plug it into our equation, we can plug it in before it's simplified, and it would look something like this. And then to simplify it, it would look something like this. And that would be your final answer for that problem. Okay? So before we were trying to come up with the information that would allow us to graph it. Now we're having it graphed and trying to come up with the information that would give us the equation. So if we look at number 5, we have a -1, 2, 3, and a +1, 2, 3. So I'm going to put down my center first. -3, +3, with a radius of, it looks like a length of 1. Okay, with a radius of 1. So as I plug this information in down here, you're going to have the opposite value, remember, x plus 3. Actually, you know what? I'm not sure if I like doing that. I want to make sure everybody understands where everything's coming from. So x minus h, which would have been your x value up here, squared, plus y minus k squared is equal to the radius squared. Okay? So again, from there, x plus 3 squared plus y minus 3 squared is equal to 1. Okay, and this is the equation, again, that I'd be looking for. Okay? All right, number 6, giving this one a shot. The center, it looks like it's 1, 2, 3. We have a, each unit, each tick mark is 1 unit. So we have a center which is going to be at 0, 3. And the radius length looks like 1, 2, 3, 4, as the length of 4. So if we plug that in, x minus h squared plus y minus k squared is equal to the radius squared. Okay? And again, simplifying that, don't leave it in this form up here. Always simplify. And there we go. Okay? Now, I would challenge you again to pause your computer right here as I do the last 3 problems down below, and just take a minute and see if you can figure out what those equations are going to have to be. Now notice, I can see a number 8 and it looks like number 9. Both of them have these tick marks are not 1. So you want to figure out what those are before you do anything else. So pause your computer and see if you can do those. All right, for number 7, I have over 7 and down 2. So the center is at 7, -2. Now, for this one, you'll see each tick mark is worth 1. 1, 2. We got 2. So each one's worth 1, has a value of 1. The radius length here, let's see. Okay, it looks like a radius of 2. Okay. So if we plug that into our equation, x minus h squared plus y minus k squared is equal to the radius squared. Well, if I simplify that, Again, remember, it's the opposite value of what, ooh, why did I put a 3? Sorry about that. It should be a 2, okay? Should be the opposite value of what was presented as the center, okay? And there you go, okay? So that would be the equation I'd be looking for that one. Now, in number 8, I already warned you that each tick mark is not worth 1, so I have 2 units to get to 10. So 10 divided by 2 is 5, so each one of these is worth 5. So if I go down 5, 10, 15, 20, the center is at 0, negative 20. The radius is at 5, 10, has a radius of 10. So if we plug that in, x minus h squared plus y minus k squared is equal to the radius squared. And then simplify. Here's our equation that we're looking for. Okay? All right, for number 9, I said that each one of these wasn't worth 1 either. So over here I have 2 units to make 4, so 4 divided by 2 is 2. So what we're looking at is this right here, 2, 4, so the center is at negative 4, 2, 4, 6, negative 6, okay? And the radius has a length of, ooh, that's interesting. It looks like it's halfway in between these two. So 2, 4, 5 units. Now let's see if that's true on going left to right. So it would be 2, 4, again 5 units. So plugging this information in, we have x minus h squared plus y minus k squared is equal to the radius squared. Okay? So x plus 4 squared plus y plus 6 squared is equal to 25. Okay, so there you go. You've got your answers there for those last couple problems. You'll find online the homework for tonight, and if you have any questions, come let me know. But like I said, I think that's pretty much self-explanatory. Thanks for listening, and have a great night.